use the square root method is when there's no b term. Always put a plus and minus in front of your square root because you don't know. A double negative is always positive and positive is always positive, so you don't know what was in there. Always separate your solutions because there are two. Okay, so what I was saying is that sometimes they will look exactly the same, and sometimes they're going to be completely different numbers. So that's what we're going to talk about. So your goal when you're using the square root method, y'all, is to always get what's squared alone. So here, x is squared. Is x squared alone? Yes. So when it's alone, you are literally just going to take the square root of both sides. Well, what does a square root do to a squared? They cancel. So square root cancels square, and I get x equals. Well, this is why we practiced square roots last week. How do you simplify the square root of 24? Is it a perfect square? No. So I'm going to do my factor tree. 2 and 12, 2 and 6, 2 and 3. What can I take out? A 2. And then I have a 2 and a 3 left over. Okay, so what I want you to realize too is what we were saying is anytime you take the square root of a number, didn't we take the square root of a number 24? So I have to put a plus and a minus. I'm taking out a 2. And what's staying in the house? 3 and 2, which gives me 6. So the second point literally says always separate your solutions so that you see there are 2. Well, that's 2. One of them's negative.
So you multiply the leftovers?
And one of them's positive. Those are your 2 solutions. Okay? Bless you. Okay, look at number 2. What's squared? What's squared on number 2? Is the 2 or just the x? Huh? Just the x. Now, if it was written like this, it would have been the whole thing. But it was not written like that. It's just 2x squared, so those are different. Okay? So I want you to realize just x squared is squared. So what do I need to do to get that alone? Minus 40. And I get 2x squared equals negative 40. Now what? Divide both sides by 2. And I get x squared equals negative 20. Now what do I do now that it's alone? Square root both sides. So when I take the square root of both sides, the square root cancels the squared, and I get x equals. Well, here I took the square root of a number, so it's going to be a positive and a negative. What else do we have to do when we do the square root of a negative? There's going to be an I. Now, I left space just in case I take a number out, because we change it to positive and put an I out front. So what's 20 broken down, because it's not a perfect square? 2 and 10. What else? What goes into 10? Okay, so what do I take out? The 2, because that's the pair. And what stays in the house? So I get negative 2i square root of 5, positive 2i square root of 5. The I always goes directly in front of your root, your radical. Because it was negative on the inside of the root. Is it okay to have a negative on the outside? Yes. It's when it's on the inside that it becomes negative. And the reason being, y'all, if you ever type, if we tried to do negative 20 to see if it was, what did I do? Non-real answer. Because it's imaginary. So if you ever see non-real answer, it's because it's going to be an imaginary answer. You're going to have an I. Okay, so let's look at number 3. What's squared? That whole thing. Ooh, it has a clear. Okay, what do I need to get rid of? The 3. How do I get rid of that 3? Divide. Don't ever multiply it in, because if you follow PEMDAS, you'd have to do parentheses or exponents first, and we're not doing all that. That would make this problem way harder. So I end up with x plus 7 squared equals, what's 54 divided by 3? Yes, ma'am. Thank you. Now, is what's squared alone? Yeah, this whole thing is squared and that whole thing is alone. So what do I do to both sides now? Take the square root. So square root cancels the squared, and I get x plus 7 equals, well, I took the square root of just a number. So I'm going to put a positive and a negative. What's the square root of 18? What goes into 18? 2 and 9. And 9 is a perfect square of 3 and 3, right? So what can I take out? The pair, the 3. And what stays in the house? Now this is where these get a little different. You're going to have 2 terms in your solution. Because remember, I've talked about how radicals are like variables. You can only combine if they both have a square root of 2. Well, this 7 doesn't have a square root of 2, so when I have to get x alone, I get x equals negative 7 plus or minus 3 root 2. So proper is to put your whole numbers in front of your radicals. Well, are those ever going to combine? No, because 3 root 2 is not a like term with 7. So my solution is literally negative 7 minus 3 root 2, negative 7 plus 3 root 2. Which is why, I think that was Friday, we practiced simplifying where they don't actually fully simplify. Not Friday. We weren't here Friday. Whatever the last school day y'all were here was. There you go. One of those days. Sometime before today. Okay, not last one. I'm going to do one more on your practice with y'all. Okay, so I want you to realize this whole thing is squared. And what do I need to move? The 3. How do I move a plus 3? So I get 2x minus 1 squared equals negative 3. What do I do? Square root both sides. Square root cancels the squared, and I get 2x minus 1 equals, always put a plus or a minus after that equal sign. Well, what happens with this square root of negative 3? I'm going to get an I, and it's going to be positive. Well, does 3, the square root of 3 simplify? No, so I have I root 3. Now what's my goal? To get x alone. So what do I need to do? Add 1. And I get 2x equals 1 plus or minus I root 3. Now what? Divide by 2. Now, when I divide, I always separate the terms. Because what if 1 over 2 simplifies? Now it doesn't here. But if it was like 2 over 2, would it simplify? Yeah, so I always separate just in case these do simplify, which on this one they don't, but some of them on your practice do. So I'm left with 1 over 2 minus I root 3 over 2, 1 over 2 plus I root 3 over 2. Woo. Okay, now I want y'all to flip to number 5 when you're done writing that down. Okay, number 5 is a little different. What do you notice about the answers on the front? Don't they all look super, super similar? Okay, they were almost exactly the same except a plus or a minus or a negative or a positive. Okay, not all of these are going to be that way. I think there's 2 or 3 of them that are like this. But first off, whoop, upside down, is what's squared alone? Yes, so what's my first step? Square root both sides. So x square root cancels the square and I get x plus 5 equals a positive or negative. Well, what's the square root of 36, y'all? 6. It's a whole number. So when I subtract 5 from both sides to get my x by itself, I get x equals negative 5 plus or minus 6. Are those like terms? Yes, they don't have a root. Neither of them have a root. Neither of them have a letter. So they're like terms, meaning I'm going to separate and actually simplify. Negative 5 plus 6, negative 5 minus 6. Well, what's negative 5 plus 6? 1. What's negative 5 minus 6? So these do not match. Okay, so this is what you're working on. I did one of them with you. There are only 12 problems. Okay, so as you finish the front, oh, didn't mean to pause it.